Hi, a pleasant day to you all. I am Kyle Castillo and this is my partner Romel Sabna, and for this video we will be tackling about algorithms in space travel, mainly how artificial intelligence works in it, and other relevant stuff that will be further discussed in the video. So let's first tackle what is AI, artificial intelligence. It comprises all the techniques that enables computers to mimic intelligence. For instance, computers analyze data or the systems in an autonomous vehicle. Usually these systems are taught by humans, which involves a lot of coding. This could also be achieved through machine learning, which is where machines teach themselves. Now let's just move on to the algorithms under this field. AI, or let's call artificial intelligence, is thoroughly applied in the investigation of satellite operations, particularly supporting the operations of large satellite constellations. This involves relative precision, communication, end-of-life management, and so much more. There is another system known as machine learning that is used to approximate complex representation of the real world. AI plays a significant role in space travel and exploration. Its applications range from mission planning and control to spacecraft operations, data analysis, and autonomous decision-making. The use of AI in space travel continues to evolve as technology advances. It enhances our mission capabilities, improves efficiency, and enables new discovery, ultimately expanding our understanding of the cosmos. AI has three types. The first type is classification algorithms. Next one is regression algorithm, and the last one is clustering algorithms. One algorithm will focus on the classification algorithm known as k-nearest neighbors, which will be further discussed in the video, which is our main algorithm of this video. Now let's move on to the KNN, which is our main algorithm. Let's first find out what is the meaning of KNN and what it is. It is a supervised machine learning method that is applied to both regression and classification challenges. It is a non-parametric algorithm that bases its predictions on how closely the new data point resembles its immediate surroundings. The fundamental tenet of KNN is that output values or classes are likely to be similar when data points are close to one another in the feature space. The foundation of KNN is the idea that latent occurrences are clustered together in the feature space. While it can be used for either regression or classification algorithms, it is typically used as a classification algorithm, working off the assumption that similar points can be found near one another. Now I'm giving the floor to my partner Robam Sapno, which will further discuss more on about KNN and how it works.
Hello, my name is Romel C. Sapna Jr. So, how does KNN work? As you can see, it works in 5 ways. So for training, we'll start off with that. It does not explicitly train a model. Instead, it stores the entire trained dataset, which consists of labeled instances. Then, for prediction, given you a labeled data point, the algorithm finds the k nearest neighbors in the training dataset based on their distance. Next, let's go to voting. This is more like a classification, where it classifies tasks, where the class label of the new data point is determined by the majority voting among its nearest neighbors. So, the class appears most frequently among the neighbors, which is assigned to the new instance. For averaging, which is regression, it regresses tasks. The output value of the new data point is computed by averaging the output values. Then you got the last one, which is choosing k. The selection value of k is crucial and depends on the data and the problem at hand. The smaller the value of k makes the algorithm more sensible. And The bigger it is, the larger the k, it smooths out the decision boundaries, but it has misclassifications, near class boundaries. So, KNN is straightforward and understandable. It's really easy, but because it compared each new data point with every training instance, it can be computationally expensive, especially for huge datasets. So, in simple terms, as you can see in the image, the KNN algorithm believes that similar things are situated nearby, which related things are located close to one another. In this instance, let's say it's a solar system, and you're going to scan the night sky with different solar systems nearby. Those things are together, and you're not allowed to separate them unless there's a body outside that's interfering with that system. So, as you can see in the image, it's kind of like that. Similar data point sets are close to each other, like a solar system. This presumption must be true enough for the KNN algorithm to be effective, which KNN uses the arithmetic we may have learned as children, where it calculates the distance between points on a graph. So, it's called distance, proximity, or closeness. So how does this work in real life? Let's say you're studying Google Maps, getting to your house or getting to somewhere else. So you're from your house, then you're gonna go all the way to Moa, for instance. And that's how you're gonna be able to call how far it is. So how does KNN apply in space? As you can see here, you can pause the video if you want to see more. So we have image classification, which you can see it's mostly for images. Then we have terrain classification. This one, it's mostly for the geological landscape of a planet, or maybe at least mostly likely the features of a planet, and it's able to identify it. Then you have spacecraft fault diagnostic. This one helps in mostly your spacecraft if there's like a problem in it, and then you guys can easily find what happens to it, and then you can just fix it really easily. Then you have data mining analysis. This one is like collecting data and then you analyze the data. And then you have trajectory optimization. This one is like charting a course quickly to point A and point B. Phew, that was long. So I'll be short here with best case and worst case time complexity of KNN. So time complexity of KNN nearest neighbors, or K nearest neighbors, KNN, algorithm can vary depending on several factors. So let's examine them real quickly. For best case time complexity, the best case scenario for KNN algorithm occurs when the dataset is well structured and evenly distributed. As you can see, if you guys are familiar with previous lessons, or at least are familiar with the best case and worst case, O1 is the fastest one, and O log n is just as fast. It's fast, it's not that bad. But then here you have worst time complexity. The worst case scenario for KNN algorithm occurs when the dataset is unstructured, high dimensional, or imbalanced. So as you can see here, O n log n it will take a long time before you can get to wherever you need to go, or at least get something done. So in summary, the time complexity of KNN depends on the characteristics of the dataset and the efficiency of the nearest neighbor search algorithm and the data structure used. So, to conclude the video, space travel uses AI algorithms to chart around the orbit of our planet, and maybe so beyond in the future. There are 3 types of AI algorithms. These are classification, regression, and clustering. Lastly, KNN is also discussed on how it works and its application in space travel. Additionally, we also tackled its best case and worst case time complexity. Thank you for watching the video, and I hope you guys enjoyed. These are now our references. A video link will be posted later on.